Well, I think that should be all for release planning. Do we want to move on to our first agenda item? Experimental components. Javier, did you put that one?
Yeah, I think it's mostly Sam, but I'm definitely interested in it. Sam brought up the question about, in particular, there's a cosine integration RFC, and it talks about sort of creating another, what is it, like build operation. And the idea was that this would be like an independent utility that platforms could use to essentially sign, right, using cosine, and do everything necessary there. The question that came up is where can this live, right? There's some complexities if we were to build this outside of the BuildPack namespace to then migrate it over to the BuildPack namespace. And we're essentially wondering if there's a way that we could kind of begin building it within the BuildPack namespace, and then essentially what are the concerns there, and attributing it as maybe experimental, and the ownership being more independent as opposed to being part of any particular team. That's more or less the train of thought. I don't know, Sam, if I did the explanation justice.
Yeah, I think there's two aspects to it. I think there's just like whether the component is stable or not, and whether a team is capable of owning it or not. So like, let's say even if the component was stable, like we need to find a good place for this where the team and their maintainers are happy maintaining it over time and they have the bandwidth to do so. I think last time it was suggested that the platform team might want to own these things as part of like platform author tooling components, but like the current platform maintainers were not comfortable with owning or like extending their maintenance responsibilities to these components, given that they're already stretched. So that's pretty much where the issue lies.
Yeah, so effectively, we want to build these things, right? Individual, maybe contributors want to build these tools. The concern is what happens if for some reason that individual is no longer able to support or maintain that tool, right? Then I feel like we've just added more stuff to our plate that we in the long term can't support or maintain.
I think I worry about, pre-optimizing a little bit, right? Like if somebody wants to build something now that belongs in the project, right? Where we have RFCs accepted or whatnot that say, yes, this is something an experience we'd like to offer, and somebody's willing to work on it. If in the future we end up in a state where it's hard to maintain to the extent that we can't even look at PRs and merge them in, right? Or like we wouldn't be able to respond to security incidents for it or something like that, right? In a really critical way, right? Then we can archive the repo. It's not or you can put something on it that says, hey, we're not looking at this right now. It's an open source project. It's not a production service, right?
I think that's sort of what we were trying to get at. Like we can just put a warning on the README that says that, like, while during the time that it is experimental, we can put out a warning that it is experimental, and that it's only meant for like use at your own risk or whatever. Like every open source component is technically use at your own risk, but let's just make it prominent and clear that it is use at your own risk. And that seemed like a fine compromise to me in terms of stability. And then in terms of long-term support, I think in general, like some point we might want to discuss how we decide which team owns it, or like even in case of components that are donated to the project, which come with existing maintainers for those components, like do they get assigned to a team, or does the project just live in a repository and those maintainers just have access to that repository to maintain and merge pull requests? But so just general things like these, like let's say like I want to work on this signer stuff, but I don't want to take on the rest of the responsibilities of maintaining like the other platform components. Right now, there's no good way to enable me to do that. Same thing, let's say like we were discussing like getting things like other testing libraries like Occam to be donated to the Buildpacks project. Like the current maintainers of that wanted to be involved with the ongoing maintenance of that repository. And like the number is large enough, like they have 5-6 maintainers that all want to have like ability to maintain those repositories without necessarily being maintainers for the entire team.
Yeah, I think that's the main problem, right? It's like we're trying to attribute ownership of repositories to a large group instead of individuals. And I think we're finding that to be challenging, and maybe even slightly unclear as to what these sort of expectations there are, right? Because according to some community doc, right, it says that the platform team manages these repositories, and the GitHub sort of rules are set up in the same fashion, right? But I feel like this, along with Occam and other things, right, like it's really more of independent maintainers for very specific components is more or less what we're hoping could be possible.
Seems pretty weird to me that you can't maintain just one repo.
I mean, it seems like a lot of overhead that if you want to maintain a set of repositories, you need like a new team for it, or you need to assign it to an existing team. Like, and that was one of the reasons why like some of these teams were a bit reluctant to donate things, because they're like, do all of our maintainers now get to maintain this new project? Do all of our maintainers now also have to maintain these other projects that the team is responsible for? And ideally, I would like the best of both. They can maintain the project that they donated. Well, if they don't want to, they don't have to maintain the other things.
Is there any issue if a new component enters a team? Is there any issue with the team level maintainers also having access to push to that repository in addition to hypothetical individual repo maintainers?
I mean, we trust the maintainers that we have in the projects. I would trust them to not do anything that the repository maintainers don't want. But I can't speak for the repository maintainers. Like if they trust the project enough to donate something to it, I think they should trust the maintainers to like not make malicious changes to the project that they've donated. So I think the other thing works fine, in my opinion. Can't speak for others. But I think what worries me is the other way around, like maintainers for a specific component now being responsible for a wider set of repositories. And they may not either want that responsibility, or they may not be like capable of fulfilling that responsibility.
Seems pretty reasonable to me.
Is that a sort of governance change, or is it just a?
It was probably something we never really thought about when the project was, platform and pack implementation, that life cycle. But yeah, I think it's probably a change to some documentation.
Anyone else has any thoughts? Joe, Natalie?
It seems like there's not much opposition. Is there an action to?
Okay. So I guess this is what we'll assume moving forward for like one-off components or like donated components, that they don't necessarily have to be part of the team if the maintainers of that team are not comfortable owning it. Or
Yeah, I
vice
think
versa.
I think we verbally agree to that. I guess the part that I was asking about the governance changes is, according to the documents, we would have to create an RFC and get binding votes to update that sort of structure, right? So is that the next action item? Could we do both of those sort of at the same time? Could Sam start the signer repository within the build packs namespace, and then have the RFC to update the governance, or do we want to wait on the governance RFC?
I think we have plenty of, like, if it's just a mechanical thing, we have plenty of repos under build packs that we don't consider maintained or like belonging to a team. And maybe in this case, it's worth calling out explicitly that it is an experiment and, we're figuring things out. But I mean, I think it should be fine to essentially, start an experiment, even if we have to back out of it later.
Are you satisfied with that, Sam?
Yeah. Cool. So I'm just waiting for approvals on that RFC now.
Move on to our next agenda topic. I think you added that, Sam.
I think Benjamin is here as well. Maybe do you want to talk about it, or I can if you don't want to.
I can start, and you can complement if I'm missing some stuff. But so basically, one of the problems we have currently is that we are using a lot of the Packito build packs internally in order to be able to build some of our services. However, there is a constant theme with all of those that typically we want to be able to set registries to hit our internal registry instead of public PyPI and things like that. And we want to do that for all the applications that are built inside our company. And we want to prevent users from being able to specify it themselves. So what we end up doing is that we end up forking most of the build packs, either to specify the registries, sometimes also for build packs that install typically the Go binary, we would need to change that also to hit something that is internal. And that means that we have a lot of work about forking all of those for something that is basically configuration. And when thinking about how we could fix that, one of the things that seemed natural to us was to actually allow builders to provide settings to specific build packs, such that the builder owners, which would probably be an operator team inside a company, would be able to say what the defaults and what is the configuration that should be used by each and every of the build packs that is running in this environment. So yes, so there might be other ways, but we think really that the builder level might be the best way of allowing typically enterprise users greater control over build packs without having to fork. Did I forget something, Sam?
Yeah, I think I can also just provide some other context from other folks who were in the BAT team meeting when we discussed this. So the other sort of use case that we gathered from other companies, for example, for Heroku and Salesforce folks, they have the same set of build packs, but with slightly different settings for like enterprise versus like internal usage. And it would be nice to be able to set things like the registries or like default to certain settings during detect and build time using environment variables or other configuration. So during build time, it's currently possible. So you inject a build pack at the very beginning that sets the like build environment for the rest of the build packs, but it's not possible during detect time. So if a build pack is trying to like, it's reading a environment during detection to figure out what it wants to do. There's no way in the project right now to configure those kind of build packs.
Does
so
the builder, sorry to interrupt. Does the builder let you set environment variable? Like if you just set environment variables on the builder image, do they make their way into the build? I thought they used to, at least. Do we clear the environment now?
The lifecycle strips out every variable in the builder except for an allow listed set of environment variables, which typically include like basic Linux variables like path, LD library path, and so on. Doesn't even include variables that start with BP or BPE underscore whatever. So even those variables are cleared out.
Seems reasonable to maybe let them through so you can do builder level configuration.
Yeah. I think there were two pieces we discussed. One was like changes to environment. The other was changes to the provisions or requirements of the build plan, essentially. So let's say there is a build pack that requires Go to be present. Like it requires Go as a requirement, and typically there's a build pack that provides it. But now let's say you want your stack to provide the Go distribution. What you end up doing is creating a dummy build pack that just checks for the presence of the Go binary in the stack and then adds that as a list of provisions. So it's not doing anything apart from just making small changes to the build plan. So that is also something that can currently be achieved by a build pack. Like you can attach appropriate build packs either to the beginning of the group or to the end of the group to modify the build plan. So it's not as much of a concern. The main thing was just like these environment level settings. And the other common use case was like downloading binaries from some sort of place. But I think that can also potentially be like a convention we agree on rather than something that's specified, because there's nothing in the spec that's preventing you from doing it. So I think if it's just during detect, we could get environment variables, or like we could expose the environment variables to certain build packs through the builder. That would be nice. With the ability to override even what the user provided. So let's say the user provided some misconfigured environment variables. As an operator, you want to override those to a certain value. You should be able to do that. So I was imagining an interface similar to like our default override prepend and append interface. So that if the builder wants, it can override a environment variable, it can default it, it can prepend or append to certain environment variables as well. I think Emily's suggestion was like system build packs is the first place where we are doing builder level configuration for some of these things. So she thought it might be a good idea to consolidate the config files where we are specifying system level build packs that are present on the builder and these builder level environment variables. So not hearing any opposition, so that just means we should just go ahead, write an RFC.
Yeah, I mean, it makes sense, and I think, as you probably heard in the BAT meeting, it's solves some problems for us, especially internally.
Cool. I think someone on the Bloomberg side will write out an RFC. Yeah. That's it, I think. If there's nothing else, we can convene early.
I wanted to check. There are a lot of RFCs that I wasn't sure if needed discussion. They haven't been brought up, and I haven't given them a lot of attention. Is there anything that we should be paying to it, paying attention to asynchronously?
I think you were absent, Joe. I don't know if this is the right time, but we could definitely bring it up. In regards to the project descriptor stuff, instead of work, there was an RFC for PackTOML. And I think that has a lot of sort of discussion going there. And I think it kind of swung back and forth. But I just want to let you know that that is now an independent RFC from the whole rest of the project descriptor stuff. And I don't know how you feel about that, if that's still something that you want to pursue going forward.
Yeah, I'll take, so there's another one besides the one you wrote?
I think it's the one that you wrote, the PackTOML one.
Yeah, I thought we were gonna kill this one. All right, I'll take a look. I know you had some stuff, and I was kind of expecting that this one would just either go away or evolve to align more with what you had proposed.
Yeah, and maybe we could just sync up asynchronously over Slack and make sure that we're clear on what's happening there.
Sure.
Cool.
There's also the images table one. What's happening with that?
Yeah, this one is tough. I feel bad about this one because it's, I think, an important thing, and I know the folks that authored it did some good work on it, but there's still a lot of challenges that I think, I'm just looking back at it, I'm not sure if they've actually been addressed or not. It's a tough thing.
Yeah, I know I put my final thoughts on there, which was basically the sort of stance that we shouldn't decompose the URL or URI, and that we could simplify the different images. So I have my kind of proposed solution. I don't know if that helps.
Yeah, I'll take a look at this. We should probably make even if the decision is no, we should probably come to a conclusion on this. I think, I think it's probably not a straight no, and more of a, one day we would like to do something like this, but there is a decent amount of burden involved in it, and there are, I mean, like there are workarounds, sort of like whether even if it's just running more builds. So. Yeah, I'll take a look at that one again. Your comments in particular.
Wanted to make a quick comment about the Docker files RFC. I think at some point we had talked about like a phased implementation where Docker files are used just to switch the run image dynamically. And I think that makes sense. I know the spec PR that I put up kind of did everything, but as I'm looking more closely at the implementation, I think it will be better if we do in pieces. So I made a comment on that PR, and I'll probably follow up with another PR to break it out.
So we want to do the switching as the first piece and then the build as the second, or?
I think the switching will deliver some value, right? So it'll be nice just to have that at a minimum. And in the meantime, we're kind of working through some questions about how Kaneko will behave, how we provide images to it, how we save images after they've been extended. And I think that will take some time, and it will also kind of pair well with other work that we're doing. So I just don't want to block the entire thing on getting that stuff resolved.
Makes sense to me. Is it only for the run image then?
Yeah.
Yeah. That would help solve a lot of things on our end, I think.
I had a question. What's the status of the, we're talking about whether we're going to integrate cosine SBOM attestations more directly into the kind of different phases, especially with Dockerfile checking thing, versus keep that interface open and then implement the SBOM format on top of that. It seems like cosine attestations have, at least the person who wrote the cosine SBOM, the other integration, is saying they don't think it's going to work anymore, or they're even moving to attestation format. Has there been any thought about what that interface should look like? It's more recent than what I'm aware of.
I think almost every integration I've seen uses attestations at this point. There's absolutely nothing that I'm aware of that uses the SBOM format.
So do we feel like we want to build that in instead of keeping the interface open?
So there were still two things, right? There was generating the SBOM and just fetching it from the attestation. There's like generation or fetching versus attaching it at the end of export, right? So I think the export attach we can sort of consolidate towards attestations, at least for the initial like cut off the signer. I think it seems fine to just support like add as attestations or nothing at all. And in terms of fetching, we can do the same. Like we can either fetch from attestation or just generate one on the fly. I think those would cover all the cases.
Is gen packages, or whatever we name it, going to do the fetching and the generation, or just the generation, and then another lifecycle component does the fetching?
So I think if it's run in local directory mode, which we discussed last time, so like in case of extensions being run, I think we need to provide it a local file system, in which case it just needs to run in generation mode. But if it's given a remote reference, whether it has to fetch them or generate them from that remote reference, it will need registry access. So in that case, I think like it just depends. Whether
outside.
yeah.
That makes
The
sense.
arguments are local file system or registry. Those are the only two cases.
But you still want the logic to live in that for fetching it. Okay, that makes sense.
I think we could try to determine beforehand if we have an SBOM in the registry. And then when we do the extension, we can just pass a flag that says you need to generate or not, right? I don't know if this is helpful, but I made a comment on the spec PR with just like a little diagram showing how Docker files and run image SBOM kind of the interplay between those two features. I think they're somewhat orthogonal, but to get the complete picture, obviously you need both. But those little squares are all, to my eye, like discrete chunks of work that, you know.
One thing or a way I was thinking about this is if we're going to standardize on attestations on the output side, and if we view whatever we call gem packages, because I refuse to say gem packages because it's a terrible name, whatever we call that, if we make that more swappable, so like you could replace it with something that isn't, SIFT, like more specific to your base image, then it feels a little weird to build in the retrieving of the SBOM into that binary instead of, having that be built in also if we make the output, and so I wonder, I don't care which way we go, because I think everybody's going to use this with cosine attestations right now anyways, but if we build one in, it might make sense to build the other in to the non-swappable lifecycle phases, or make both generic.
I'm
It's not a
thinking
very
about
strong
this
point. Sorry.
again. We needed gen packages because we wanted to get the run image SBOM in the app image, right? Inside the app image, not attached to it, but inside the app image. But in the last meeting, we decided that it was fine to just leave it out of the app image, right?
I think we wanted a way of, like, I don't know if the reason it needed to run in the image was so that the SBOM ends up baked into the image. I think it needed to run in the image so we can have a like user provided way of generating the SBOM without having an external tool that has to pull all the image layers separately from the build pack process. It's like if you're running in an environment like Tecton, right? You don't want to point a tool at an image in a way where that tool has to pull the image again separate from Kubernetes Docker daemon, right? You want to execute the tool in the context of a running container. And I think that's why we ended up with the architecture where it needs to run on local file system instead of something where you point it at an image and it does the analysis. It's a performance thing. But I don't have a terribly strong opinion about it. It's just from memory.
Because I'm just thinking about it now, like if the run image SBOM is no longer in the app image, and the signer binary is all already going to attach the SBOM appropriately. Is there any need? Like there's no requirement apart from optimizing the performance to run it during the build phase. It also makes it easier to just swap out the last signer binary to whatever you want. And
it's not clear what the alternative you're proposing is.
I'm just saying don't run gen packages at all, and then just run it at the end after export to attach it as an attestation. And the tool that's attaching it as an attestation can, the only thing is like it will have to pull the layers again, but that's it, right?
So I worry about if gen packages is going to be something like SIFT. I don't want to point SIFT at an image that has the build pack layers in it, because it'll pick up on the same things twice, because the build packs are also going to be running SIFT on the right. And so you want to run SIFT on the run image, not on the whole generated app image, right? And if you did that, you could do that out of band of the, like not inside of the container, but for a platform that's container based, where you're relying on the platform itself to cache the layers of the different containers you're running, it's going to be a lot less efficient to run the SBOM generation tool from inside one of those containers against a remote image, where it has to, on every build, to repull all the layers, right? That's my big worry. It's like, I'm thinking about this across many builds on an application platform, right? And any step we have which says, I'm going to pull an entire image in the context of a container, right, without relying on the platform's ability to cache layers, is going to be a big performance hit.
Yeah.
And SIFT works great if you run it on the image.
Well, SIFT works with Docker daemon. It won't work on Kubernetes with the container, like with the container DE storage backend, because that's not exposed. But if SIFT is running on something with Docker daemon, it will first get the layers from Docker daemon. It doesn't pull them again.
But you don't, SIFT isn't going to, if SIFT is running in an unprivileged container with no credentials inside of like, you don't want SIFT to have access to your Kubernetes Docker daemon anyways, right?
Yep. I mean, yep. Yeah. Is it something we're willing to add later on?
The ability to scan externally?
The ability to scan inside the container itself. Because the only issue with that is like bundling this binary somehow into the builder. So like the issue I see is like, if this is a standalone container image that's shipped by the project, that's signed, verified, and you give it registry access, it's similar to our other phases, which are trusted and currently have access to these things. If you invoke it inside the builder, you're running all of this essentially in untrusted mode and giving it access to the entire file system. And then you're also giving it access to the registry to attach the attestations. Or no, wait, we're just outputting it to some folder, right?
You run it inside the, so I'm not sure which use case you're talking about, but if you're talking about the case where it runs inside, where the scanning happens inside of the container and is invoked from inside of the container, you'd run that at a run image, right? In a separate, wouldn't run on the builder. It would run in a container, maybe started by the platform that uses the run image as a base image. And it would run in there and then output, need no permissions or privileges or anything, because it's just scanning the local file system. And then output to maybe a file that gets picked up that's actually in a volume or standard out or however you want to do it.
So yeah, like, wait, so the binary would have to be attached as a volume to the run image. Like, how do you get the binary in the run image so that it can?
Yeah, you'd probably want to mount it in as a volume. I think that seems.
But then
like
you're
what
fetching,
most platforms are doing in that use case.
You're probably fetching this binary from an existing image as well, right? Like, we'll be shipping this binary as an image.
Well, So in the original proposal, gem packages is something you include. It comes with the run image, right? And then we decided to move it outside of the run image so that it's, you don't have to modify your run image as much. So if you want to get it back in the run image again, right, then you need to do a volume mount of.
I think just put it next to the life cycle, because the extender, like the extender is going to run the container where the run image is going to be extended already includes the extender. If there's a gen packages right next to it, like, can just invoke it.
But we didn't want this in the lifecycle image, right? Or like we decided to create like some sort of a different container image or bundle with all of these binaries, or did we end up deciding to include it in the lifecycle image?
I think there are two binaries. Maybe I'm going to paste a diagram that I made that, again, may or may not be helpful, but I think there are two. Where's this thing? There are two binaries. There's one binary that's like, I know how to locate an SBOM. Like, give me an image. I'll see if there's an attestation, And then there's another binary that knows how to generate an SBOM. And they kind of have to like communicate. So let me paste this diagram. I've been thinking about this for a little bit. Oh my gosh, that's a long link. There's a shareable link.
Oh, wow. You've been thinking about this a lot.
Yeah. The main thing that I can share my screen if that's helpful. Let me see. You see this thing? The flow?
Yeah.
So the idea is like, okay, you have analyze, you have detect, you do the generate, you generate Docker files, and then somebody, probably the platform, basically needs to look for an SBOM. And you can kind of ignore this local registry thing for a moment, but it's like, the idea is like, I know if the run image is just getting switched to another image that exists in my registry, right? So I'll go look for an SBOM that's associated to it. And if I find it, then when I run the extender, I can tell it, oh, you don't need to run gen packages, right? I already have an SBOM.
Just to stop there for a second, is there a reason that it matters if the run image changed or if the extender ran or not? It seems like at the end of the extend phase, you always end up with a digest that you could have ended up before, even if you reran the Docker file. And it probably always makes sense to check for an SBOM associated with that digest, just so you don't have to generate the same SBOM again for no reason, if that makes sense.
That I'm not quite sure how to do that and also avoid giving registry credentials to the container that runs the extension. That seems a little risky.
Are you going to have to, in the case that the Docker file ran and it generated a new thing and there's not, and it generated a new thing, aren't you always going to have to do that anyways?
I thought about this little dance. I'm currently, so Kaneko has a way, I don't think it's going to work for our purposes, but it has a way that you can provide base images just on the file system, right? So you could like kind of pre-pull all of the base images that you'll need, and you just give it to Kaneko, and then it can apply the Docker file. The problem is that the output is either going to be into a registry or into OCI layout, which you can't chain together for the next Docker file, just without changes to Kaneko, right? So that's something that we could look into, maybe modifying it so that it's easily chained together. If we did that, the final image could be, OCI layout on the file system, and you never need to talk to registry at all, right? Or you could spin up a local registry, just to use as the interface, but it doesn't matter. At the end of the day, we're using the file system to shuffle, put the bits in, do the extension, pull them out. It would be great not to have any registry involved, right? Or like a secure registry where you have, sensitive stuff that you don't want to expose to random Docker files, right?
So this would only happen if all of the container images here did not have attestations attached to them. Or the final one didn't have an attestation attached to it. Because let's say there's an attestation attached to it, then we probably want to fetch that instead of generating it from the local file system. And the attestation won't end up on the local file system.
Well, if any Docker files run, it invalidates any attested SBOM, right? And so it should, because you've changed stuff, right? Like you can't just append to, if you run a Docker file, sorry.
It's just a list of froms, like you just did a switch.
Oh, you didn't modify anything. It's the same thing though. My point is just like, all that matters is the digest of the final thing you end up with. Because if it changed 10 times, the earlier ones don't matter, right? And so my question is just, can we, instead of having logic to figure out whether things changed or whether Docker files were run that's related to determining SBOM, can we just always take that final digest we end up with at the end of the extension process, no matter what, right? And say, is there an SBOM for this? If so, I'm good. If not, I run the thing.
Yeah.
I think the problem will be like doing that all in one container, right? Like you could just run gen packages and then you can still look for an SBOM in a registry and prefer that one to the generated one. And in that case, why are you running Docker files at all, right? Why don't you just switch? Like, why are you going through the process of building a new image that's just exactly the same as the one that you already have? In that case, we could warn or like, I don't know.
So hold on. The problem is, the thing you're worried about is you've done this extension phase inside of the image. Maybe it's changed some stuff and maybe it's run some Docker files. And at the end of that, you don't want to run something that then needs to reach back out to the registry, but you would need to reach back out to the registry in order to know whether or not you're supposed to run gem packages on the system, right? I see.
So like what I don't get is, if you're running this extension, all you're doing is froms, like switching base images. You don't even want to be downloading these images, right?
Yeah, that's an optimist. So that's what, like, going back to the first thing that I showed, like that's this one. There will be actually no like separate container for extension, right? You just like, I can skip this whole thing. I already have the run image, proceed to export, right? And I think when we add the ability to extend, we can keep that optimism, we can keep that shortcut essentially, and know whether this extra phase can be skipped. So this optimization, where it is, oh no. This thing where we check to see if an SBOM exists in the registry first can always still happen.
I guess like we're introducing all this complexity because of optimizations, right? Like we can just start with the signer looking at the run image digest at the very end. Like it doesn't need to scan the entire app image. It will take the app images as SBOMs as it is. It can fetch those from the layer. It can get the run image digest from the lifecycle metadata. Run the scan on that. If the run image has an attestation, it attaches that to the app image. If it doesn't, it generates one, attaches that to the app image. Like we can skip all this gen packages dance for now, go through that route. If people complain about optimizations, we can always come back and do it, right?
But are you proposing a change to the interface though, where the gen packages tool can't run in the context of the container? It has to pull the image and analyze the layers.
Yeah. It has to pull the images and analyze the layers. It doesn't require Docker daemon to do it. It has to do that only.
I understand what you're saying. Just in the I worry about the simple case in that situation, right? Where you are starting with a run image that isn't extended with any Docker files, right? And you you have to, and it doesn't have an SBOM attestation. In that case, you have to pull the run image every time.
Or every time you do a rebuild or a rebase, yes.
Right, and that seems, and it's not just once per Kubernetes node that the build is running on, right? It's like once per build for every build. It has to pull the entire run image.
I mean, it's. I think we can't just have partial supply chain security, right? Like if you're trusting run images to not have SBOMs and stuff, and then just like relying on our build process to create one for you. I get that case for when they're extending the image that they can't provide one. Like if you're just switching the image, I don't see why people would do that. And if they're doing that, like they'll still end up with the correct SBOM. It's just gonna take them a while.
Well, I'm not advocating for not generating the SBOM for the run image. I'm just advocating for an implementation where we pull the run image first and then run gen packages. Sorry, we pull the run image using the platform's tool for pulling images, and then we run gen packages in that running container in the context of the container, instead of just running the tool against the bits in the registry, so that we end up, it's the same outcome, right? You always end up with the SBOM of the generated image at the end. The only difference is that the layers can get cached by the platform.
But they can get cached by the platform without needing to run that during the extension phase, right? Like for example, Sift has a volume where it stores cached layers. If the platform wants to, it can just reattach that volume during the SBOM generation phase, and it will just look at that instead of repulling the layers.
But that's not safe to use across tenants though, right? Like you wouldn't want that to, you wouldn't want to share that cache. Sorry.
It's digest based.
Yeah, but
how would you cache poison? Like we wrote that trusted tool that like that ensures that it's generating the right SBOM. It's looking at digest, and if the digest matches, it's just skipping a bunch of steps.
right now, you don't have to share, if you're running on a large multi-tenant platform, you don't have to trust the build pack tooling to preserve tenancy between individual tenants. You can just rely on the platform to do that, right? For caching, you can rely on the platform's cache of whatever, if it's a container platform, whatever images it's pulled. But it worries me, that you can make a pretty strong security guarantee there. We could just rely on Kubernetes, right, to do the isolation. Now you're introducing a cache that's shared across tenants, that relies on the build pack tooling, right, in order to preserve tenancy, and that worries me.
Preserve tenancy?
Preserve isolation between tenants.
Right. It's not on us, right? It's up to the platform to make that decision. You can provide them, like it's the same thing as the volumes that are mounted during build time, right? Like there's nothing preventing a platform from actually mounting shared volumes across multiple builds. It's just that the platform may choose to not do that.
Yeah, but right now it's just at the application layer, right, where there may be, or it's just application layers that you would, have to decide, ooh, do I want to trust this tool more, right, to separate. It's not the base images, that potentially larger base images that the builds were on top of, or the run image. We could pick this up at office hours.
Yeah. I think for me, it was just the simplicity of it all. Like we can get something out easily if we skip all of this, and the spec is simpler. it's also one less thing that the lifecycle has to worry about. It doesn't need to know about attestations at all.
I want to make sure, or I'm not completely opposed. I just want to make sure there's not a way to not have to deal with any of the problems. I want to think through it more and make sure there's not a solution that both preserves the caching and doesn't add complexity to the thing. If that makes sense.